Bismillahirrahmanirrahim. Welcome to the new lecture of physics. Today we are going to study about electric current, or we can say it, current. So what is current? The first thing which is keep in mind, current is always flow due to electrons. If you have a conductor, let's see, this is your conductor, and you have electron. So if you want to find a current in this conductor, so the current in this conductor will be due to electron. So everywhere if you wind up finding a current, so where we have a number of free electron, so due to number of free electron means which cannot make any kind of a bond, which cannot make a bond. So that's electron called free electron. So free electron, whenever we have a free electron in a conductor, so there will be a current. Okay. So we can define the current, the rate of flow of charges. The rate of flow of charges or the rate of flow of electron is called electric current. So how we can write it mathematically? So current is represented by I. So current is always is equal to Q is charge. So rate of the flow of charges, the rate of flow of charges is called electric current. Okay, it's simple. Q is a charge, T is a time. So the T mean a rate of flow. Q is charge. So rate of flow of charge is called electric current. So simple. So electric current is measured in ampere. So this is this is the SI unit of current. What is the SI unit? Is ampere. From this equation, so from this equation we want to find out the units of a current. So unit of a charge, unit of time. So what is the unit of charge? You know about that. So that's a coulomb. So unit of charge is coulomb and unit of time is second. So 1 ampere. So we can say 1 ampere. If you want 1 ampere current, so 1 ampere is equal to 1 coulomb divided by 1 second. So how we can define 1 ampere current? So definition will be like that. So 1 ampere can be defined is flow of 1 coulomb charge through a certain area in 1 second. Certain area mean this is your conductor and you have a charges here. So he say that 1 ampere can be defined as the flow of 1 coulomb charge. Let's see, this is 1 coulomb charge. So later on you will know about 1 coulomb charge. So flow of 1 coulomb charge through a certain area. Let's say this is the area in 1 second. So how many charges is going to be passed through this area in 1 second? This is called 1 ampere. So now coming to, so when the charge move in a certain direction, so what does it mean? Let's say this is a conductor and we have a charge inside a conductor and all these charges is moving from left to right. So when the charge move in a certain direction, so when a charge move is meant there will be current. So it generates a electric current. So but there are two type of charges. You know about we have a two type of charge, positive charges and negative charges. So one is positive charge and one is negative charge. So when the electron or the negative charge move in a certain direction inside a conductor, so the same amount of a whole or positive charge move in the opposite direction. If the number of charges like 5 electron is moving in the right side, so a same number of proton, 5 proton have a positive, the same number of proton will move from left to right. Okay, so it's just basically the concept behind the electron, because we have electron proton in the same conductor. So due to number of electron and proton are due to positive and negative charge, we have a two concept behind the current. So the first concept behind the current is conventional current. What is conventional current? It's imagine we just make a image about that we have a conventional current. Okay, second one is electronic current, which is practical, which we use it in our daily life. So I will define you what is conventional and what is electronic current. So simple is conventional current due to positive charge. When a positive charge is moved, so there will be a conventional current. So electronic current, when the current is due to negative charge, when the current due to electron, is called electronic current. So just so simple definition. So now coming to the conventional current. What is conventional current? It's also called positive current, and it's due to the flow of positive charge. What can say? Let's see we have a battery. Let's see we have a battery, and we have a positive charge and we have a negative charge. Okay, and this is just like we can say circuit. When a charge flow due to positive charge, so what is mean that when the current is moving from positive to negative, from positive negative, that's called conventional current, and we just image about it. This is a conventional, it's ideal case. Okay, so what is electronic current? So it is also called negative current, and it is due to the flow of negative charge. Flow of negative charge or flow of electron. So this negative current is usually represented by IER. You can be using I. So how we can represent by now? Let's see, this is the battery. We have a positive charge. We have a negative charge. This is our desired circuit. So when a charge move from negative to positive, so this is called electronic current. So it's just like, it's so simple definition. Okay, so you can also be or write like that, and you can also be draw circuit, this circuit in a exam, or whenever you can teach to some people, so you can be explain it by this way. So now coming to the current electricity. So first of all, coming to this image. So in this image, if you can see, we have a positive charge, we have a negative charge, and positive move toward the right and negative move to the left. So one thing, we have a battery. So a battery have a positive and negative terminal. Okay. Well, so when we have a battery and the conductor is inside the battery are connected with the battery, so this battery is going to make a electric field. This is electric field. So I will tell you what is electric field in the next lecture, but just keep in mind electric field. So when electric field is present in this area, so the direction of an electric field and the direction of a negative charge will always be opposite. So if electric field in this direction, so the direction of current will be in this direction, will be totally opposite, like it will be in a 180 angle difference. Okay, so I will tell you now an explanation, so how it can happen. So you can see an electron in an electric conductor. So you know about conductor. Conductor is like in the Farsi we can say it hadi. So in an electric current, the charges move in a random direction. So first of all, you can see this image. So let's see, this is a conductor. So the charge is moving in the random direction, more positive to negative, negative to positive. There will be collision and so on. And the rate at which the charges pass through it from a right to left is the same as the rate at which they pass through it from left to right. Thus the current through the conductor is zero. So now the current is zero because same number of negative charges is going from left to right, and the same number of positive charges is moving from left to right. So if see, we can say 5 electron and we can say 5 proton. So 5 electron is negative 5, so it will be, the result is 0. Okay, why? If you have 5 electron, let's see, 1 2 3 4 5, like it's a 5 electron, and electron have a negative charge, it's totally negative charges, and we can say positive or proton. So in proton have a 1 2 3 4 5, and we have a 5 proton or 5 positive charges. So you know positive and negative is attract each other. Okay, opposite charges always attract each other. So it will make a bond with this one, it will make a bond with this one, it will make a bond this one and this one. At the result, we don't have a free electron. Free electron mean which is free due to which is free because of bond, which cannot make a bond. So we don't have a free electron. It means all the electron and proton are conserved and they are made in a covalent bond or just in a bond, so don't have a free electron. So at such case, because uh, we say that current is due to a free electron. When there is no free electron, it means we don't have a current. So that's why the current to a conductor is zero. So if the end of the conductor are connected to a battery, now what we are going to do, the conductor is going to be connected with the battery. Battery have a positive and negative terminal. An electric field E will be set up within a conductor as I show you in the image. In a conductor, free electron are present in a large amount, so these free electron experience a force due to electric field. Electric field is like a force. We have electric field and electric force. And electric force will be applied on a electron and a proton as well. So, but it always be effect on the electron. So in the opposite direction, electric field and electron will be in the opposite direction. So these free electron move with a certain velocity due to this force, and the direction of motion of electron is opposite to the direction of electric field. If you can see this example. This, so we have a positive and negative charge. Initially that will be in random. Then what we say, then what we will do, we take a battery, a term is connected, the conductor is connected with the battery, and electric field is set up. When electric field is set up, so the direction of electric field and the direction of electron is going to be opposite. So it's opposite, so the electric force which is due to electric field will be applied on a electron and the charge will be moving in this direction now. So this motion of electron inside the conductor gives a rise to the flow of an electronic current in a direction opposite to the electric field. Okay. So now coming to the more important topic, which is Ohm law. So what is Ohm law? So let's see, we have a conductor. Let's see, this is a conductor, and this conductor is connected with a battery, okay, which is negative and positive, and this there will be electric current in this direction, negative, positive, electric. So what Ohm law said? If voltage is applied across a conductor, so it will be positive, it will be negative. When a voltage is applied across a conductor, current I, current I flow through it. So the current I will be flowing a conductor. So this is called Ohm law. So when voltage is applied across a conductor, so it means when a voltage is going to be increased, the current is going to be increased. So just keep in one thing, when we are removing the proportionality, so we will use a constant and the constant will be R here, and this all is called resistance. What? Resistance. So keep in mind where we will use Ohm law, so the position where we use Ohm law, where we have a resistance in a circuit. When we have a resistance in a circuit, so we will apply Ohm law. Otherwise, we will not, because we have a resistive circuit, we have a capacitive circuit, we have a inductive circuit. So when a capacitive circuit and inductive circuit is there, so we cannot apply Ohm law. But when a resistive circuit is there, so we will apply the Ohm law. So it's a history in early in the 19th century. God Ohm has a law which is known as by Ohm law. According to this law, the current flowing through a conductor is directly proportional to the applied voltage as long as the temperature is constant. Okay, so this is Ohm law. V is equal to IR. V is a voltage, I is a current, R is a resistance. So keep in mind this formula, because this formula is more important, and everywhere we will use this form everywhere when we have a resistive circuit. So keep in mind and memorize it, and especially memorize about Ohm law, a concept where we will use the Ohm law. Okay, so let's, this is your circuit, this is resistance of a conductor, this is your battery, negative, positive, and the current is going to be flow from negative to positive, from negative to positive. So so Ohm law will say that voltage is proportional, directly proportional to the current. So now coming to V is equal to IR formula, where R is a constant known as resistance of the conductor material. The value of the resistance depend on the nature, dimension, and physical state of a conductor. Okay, it's just all about the nature. What kind of a conductor we are using? We are using copper, aluminium, NDM, etc., etc. Dimension, the dimension mean about the thickness, how is the thin or is the thick, physical state of a conductor, how the conductor is, it's the iron, it's gold, what is it at? And it is the measurement of the position to the flow of current. So resistance, whenever you have a resistance, it's a position. When you are going to somewhere, like when you are going on the hiking on the hill, so the hiking on a hill is a resistance basically. So this so the resistance in the conductor also a kind of a position force. Okay, so we want to find the resistance of a circuit using Ohm formula, yeah, Ohm law. So V is equal to IR, as we proved it before, V is equal to IR. So we need to find R. So R will be here, R will be here, and I will be divided. So we can find current V divided by R, and we also can find R is equal to V by I. So we have these two formula. We will use it later on in a numerical. So Ohm law we can also write in this section. Ohm law can also be write in this. So this equation means that the greater the resistance, okay, this is more important. When a resistance is going to be too much, resistance is too much, so smaller is the flow of current, because the resistance is too much. When resist too much, so current will flow in a circuit so slowly, because resistance is too much, and this is not going to allow a current to go faster, to flow faster. Okay, so according to this formula, the when the resistance is going to be increased, so the current will going to be reduced. So from Ohm law we can also write R is equal to V by I. The unit of resistance can be defined as, what will be the unit of resistance? So the unit of resistance is Ohm basically. So how we can define 1 Ohm? So 1 volt and 1 ampere. So the resistance of the conductor will be 1 Ohm if the 1 ampere of a current. How many? 1 ampere of the current flow through a conductor at an applied voltage of a 1 volt. This is called 1 Ohm resistance. Okay, so this is was your lecture. So hope you guys will find it well and you will get your information. So if you guys have any question regarding the lectures, you can comment, you can comment and you can ask for me, so I will be willing to answer it. So thank you for a time, thank you for your time. So watch my video, like my video, and subscribe my channel. Thank you.